when people wrote down identities like this, I found it very difficult to think in terms of those. See, what does this say? It says that the inverse cosine of x is pi over 2 minus the inverse sine of x. And I couldn't remember why that would be true. Yet the funny part is, if I let, let's go back to the top now and start. If I let y equal inverse cosine x and try to draw what that really says, see, again, I have to be careful about one-to-oneness and what have you, but if I just mechanically translated this, this would say what? X equals cosine y. Cosine y is x. That's x over 1. I've written it that way. Well, you know, look at it. If this angle is y, it's kind of clear that this angle is pi over 2 minus y. Now, in this familiar environment, how difficult is it for me to see that the sum of these two angles is pi over 2? You see, in that familiar environment, it's almost so obvious, I wonder why anybody would want to point it out to me. Yet notice that from here, how do I read this? See, what's another name for y? In the angular system here, y is that angle whose cosine is x. See, it's inverse cosine x. What's pi over 2 minus y? Pi over 2 minus y is that angle whose sine is x. See, notice that the side that's adjacent to y is opposite pi over 2 minus y. At any rate, pi over 2 minus y can be named inverse sine x. And so from this simple thing, simple because the language is familiar to me, I get down to the result that inverse cosine x plus inverse sine x is pi over 2, from which, of course, this step here is a triviality. See, again, when we often deal with inverses, one of the fringe benefits that we have is that when we get stuck, we can always reduce the given result, reverse the terminology, so to speak, and return from the inverse language to the original language. See? Now, again, let me point out that once you have a result like this, all the results of calculus work the same way as before. For example, suppose somebody says to me, gee, I wonder what the derivative of inverse cosine x is with respect to x. To be sure, I could go all through this again and mimic the results of getting the derivative for the inverse sine. But notice now, by this result, this is just the derivative with respect to x of pi over 2 minus inverse sine of x. Okay? But this is the derivative of a difference. And a derivative of a difference is the difference of the derivatives. And pi over 2 is a constant. So the derivative of pi over 2 is 0. I already know how to differentiate inverse sine of x. I've done that before. So I want what? Minus that derivative. See, I want minus d dx inverse sine of x. And that in turn is just what? Well, I'll write it over here. It's just minus 1 over the square root of 1 minus x squared. And again, another result, but obtained with a minimum of new knowledge. Now, I could go on, but I think that from here on in, it's much easier for you to dig out what you want on your own. See? I had some other material that I thought I would give you, but I think that this would just turn out to be a little bit on the boring side now.